So,
All right, sir.
okay, Uche, can you hear me?
Yes, sir. Yes, I can hear you.
Okay, that's perfect. So we are going to start. No need to wait anymore. Today's class will be all about background task and unit testing. So you may be wondering why background tasks are important and why unit tests are important. So we'll first look at the theoretical part of it, and when we are done, we'll start writing the code. So when you're building, there will be certain situations in which you are running let's say an expensive computation, and you don't really need the user to wait for the result of this computation to be available. All right. So in these kind of situations, you can like return a response. All right. Then run the process in the background and send the result back to the user later. A very good example is let's say there is one file sharing app that I came across some weeks ago, in which you can use the platform to share files with other users. All right, you upload the file you want to share, then just click send. All right, so the whole process of compressing this file and then transmitting this file to the user is an example of an expensive computation in which the user doesn't really need to stay on the loop and wait to complete, right? So that's where background task comes into play. While using background tasks, you can maybe get the data, all right? Then process this data on the background and return an immediate result to the user, and the user can then proceed to something else. Like, do you have any question concerning that?
Okay. No, no question for now.
Okay.
None
So
for me.
I guess let me recap. A very common example is email sending, right? And let's say you are building an API, right, that requires user to register. And when users register, you need to send an email confirmation, like send a link to the user to, okay, like send a link to the email address this user entered, all right, so that the user can probably or possibly confirm the email address to maybe avoid spurious signups. So the process of email sending takes time. On average, let's say your server needs to perform a DNS handshake with the email API, then transmit the data and all of that. So the whole process will take up to maybe 1 to 2 seconds, right? And this 1 to 2 seconds is just wasted time. Right? We don't really need the user to be available when this email is sent. Okay, we want a situation in which the response can be returned to the user as soon as possible. And this expensive computation, this computation that takes time, that takes a whole lot of time, can then be run on the background. All right. So that's where background task comes in with Fast API. So apart from Fast API background task, there are other tools you can use to accomplish the same purpose. The first one is Celery. You can use Celery for that, but Celery is a little bit more complex to set up. You need to have a messaging system like Redis or RabbitMQ. Then you need to like go through a whole lot of setup, all right, which for simple use cases doesn't really make any sense, all right? So the this background task class provided by FastAPI is a whole lot simpler to just integrate into your endpoint and proceed from there. So I'm going to give a little example to demonstrate what I really mean. We will create an endpoint that that mimics an extensive computation. All right, we won't really send an email or maybe perform real-time computation. All right, but I'll just use a time function, like time of sleep. I'll sleep that function for like 5 seconds to mimic a computation that took 5 seconds and then return the result to the user. Then I'll work on like improving that endpoint so that this expensive computation can then be run in the background. And when the result is ready, it then gives the result back to us. All right, so let us create a folder for today's class. I believe today's class is class 11. Wait, so I believe my voice is loud enough, right?
Yes, I can hear you clearly.
Okay, perfect. So I'll create a folder for class 11. Then we'll cd into that folder and create a project. As usual, the first thing we need to do is to create a virtual environment, then install FastAPI. So I'll do that with Python 3 minus -env env. Okay, so while waiting for that to complete, I saw that you guys had issues with the last task that was dropped on your channel, right?
Okay. Yes, I like when I read it first, just like I pointed out then that it's, it was like, how will you return an exception when it's optional? But I checked, I understood the point, but at least I made some research and I saw how to like raise an exception. I tried to do it the normal way where you just write if if condition is not met, raise HTTP exception, something, but it didn't run. When I tried to run the code, it was telling me HTTP exception takes no argument, something like that. So I found another way to use JSON response, something like that to rate it. So that's how I did my own.
Okay, it's entirely possible to use HTTP response. The whole purpose of the task is to help you get to understand more about error handling with FastAPI. All right, though it's possible for you to maybe manage the kind of data passed to your application using Python. All right, but being able to do that manually from code, it's very, very, how do I even put it? It gives you that flexibility to do whatever you want to do. So that's why the task actually came up. And it's not really difficult task, it's a very simple thing. You simply get a file that this file can be optional, all right? Just make it optional, meaning a user can submit this file and a user can choose not to submit this file. And if the user doesn't submit this file, it should the default value will be none, right? You just have to check within your code. If the value is none, you raise an exception. Then if it is not none, you return the valid data. So that's just it. It's not something very difficult. I hope you understand me.
Yes, okay. Maybe that is where, because the way I wrote my code was I used that optional, then I put equal to none. That's in case nothing was given, it to be none. And I used an if statement that if file, that is if not file, which means if file is not given, run this HTTP response. So I did it exactly, but it was telling me there was a error. This thing was giving me that HTTP response does not take argument. So maybe it's because
maybe it could be due to the way you raise the HTTP response, or and HTTP response gets status code and detail. Are you sure you?
Yes, I did everything exactly. Yes.
Okay, maybe you can try it again, then screenshot everything and send it over to me on Slack so that I can take a look.
All right, so I'll do that. I don't know, Mikey. I don't know how he went about his own.
Yeah. The way you may describe, that's how I run my own code. Yeah. I just checked if the file was not submitted, then you raise an exception and it works fine.
Okay, no problem.
Okay, so Uche, you can try it again, and if you have the error, just screenshot everything and send it over to me so that I can.
All right, I'll do that.
Okay, so we are done creating the virtual environment. The next step is to install what we need, and before we do that, we should activate the environment. So we are going to activate it with source env, then scripts activate. V. Yeah, activate. All right, that's activated. So we need to install fast API. Along with all the required dependencies. All right, the installation is complete. So I will deactivate this virtual environment. I'll open my VS Code from to deactivate the virtual environment. You simply use the deactivate command. Sorry. All right, that's deactivated. Then I'll open my VS Code. Okay, the next step is to activate this specific instance of the command line. We'll create the file we're going to work with. I'll call this background. Touch. So we are going to create.
Okay, sir. The sound is somehow, your audio is somehow.
Okay, like how is it exactly?
It's as if maybe it's going up and down. Like when you stop talking, is everywhere just quiet. When you talk, there's a kind of feedback loop, as if you're using microphone or something, kind of noise.
Okay. I'm using my earpiece.
Okay.
Did you have this issue?
It's still happening. I'm not whenever you speak, it's like the volume is low. I can't hear you.
Okay. Is it better now?
Yeah, okay, yes. I think it's better, yes. Mikey,
Okay.
okay. His mic is still here.
All right. I think I can see the reason. I need to like bring it a whole lot closer to my mouth. That's the issue.
Okay.
So we are going to create a simple project here, and this project will have one endpoint, and this endpoint doesn't do much. It just returns hello when you send a GET request. So as usual, we'll import fast API from fast. Then I'll instantiate an app. After that, we'll decorate the endpoint. Accept and yes, it will accept the GET request, but then we are going to define a function that will be executed when that GET request goes through. So I'll call this function home, and it should accept. I want this to return a simple hello world message. Right, so if we test this endpoint, you shouldn't do much. Right? It will just return hello world. But that's not what I want. I want to mimic an expensive computation. Let's say we have, let's say we are sending an email to the user, or we are running some literal computation. So try and mimic that so that the request to this endpoint will not respond immediately. It will take something like 10 seconds to respond. So let us go about that. Now I'll create this function. Let's call this expensive. And expensive takes an email argument. And let's say it just prints that email. Now, I don't want it to just print the email for now. I want it to take time. All right. I want to mimic an expensive processing. So I will use the time library and enforce a sleep of 5 seconds. So before this function actually prints this email address, all right, I want the function to sleep for 5 seconds. Let's just assume that it is running a computation that is very expensive, consumes a whole lot of CPU, and takes around 5 seconds. So then time the sleep. It is sleep for 5 seconds. Now let us integrate this processing into our endpoint and test it out. Okay. No need to collect anything. Just pass it. All right, so we are going to run this example and see and observe the result.
Okay, this sound is still somehow, it's like going up and down. It's almost like it's echoing or something.
Okay. The issue is when I take the earpiece a little bit farther from my mouth, that's when you see that. But it's better now, right?
Yes. It just as you are talking, after like some seconds, it just dims very, very quickly, then comes back up. It's going up and down, up and down, up and down.
Okay,
But
it
let's
echoes.
yes, it echoes.
Maybe we'll manage that for the class today. Then I'll try and fix that up at the end of the class. Sorry about that.
All right.
So we are going to run this function now. Foreground by then up. Okay, Uche, you said that that extension you spoke about. What did you say is the name?
Thunder client.
Okay, let's look for it.
Yeah, that's it. Yeah. If you just install it, very simple.
Okay.
It shows up here. That thunder icon by the left side of your screen. Just click it by the left
By
side.
the left. Okay.
Yes. You click it, then click new request.
Okay.
It opens a new tab. Then you can see everything here. You select.
That's nice. That's nice.
Yeah.
Thanks. Okay, so let's try this. Okay. Wow, that's thanks for the solution.
Professor.
All right, so as you can see, this request took 5 seconds, 5.04 seconds. So to better demonstrate what we have, let me comment out that expensive computation and send a request to this endpoint. Yeah. How much time did you request it?
Let me see.
This 30 milliseconds.
Yes, 30 minutes into the class.
Yeah, it's 30 milliseconds. But if this computation is here, it's going to take a little bit longer because we've executed time to sleep at that expensive function, and we want this function to sleep for 5 seconds. So when we execute that request again, it takes 5 seconds, approximately 5 seconds. So after 5 seconds and 1 millisecond, we now have the result. All right, so this is a problem. Actually, this is a very, very huge problem. Let's say, like I explained earlier, this is an endpoint that is used for user registration. Users need to be notified after registration so that they can confirm the email address. All right, it really makes sense to maybe get the user to wait for this computation to complete before returning a response. Right? We don't want that to happen. We want a situation in which the user sends a request, the request is processed, and the result is returned immediately. Then that expensive computation is executed on the background, not on the foreground. Okay, so the goal of this change we are going to make here is that while this expensive computation is still executed, it will be executed on the background, and the user will be able to get this request response a whole lot faster. So to do that, we are going to import background task from Fast API, and we are going to add that to the path. So this you background of type background task. Then the next thing we are going to do is we are going to add that task to the background. Now background task dot, it has an add task method which you can use to pass in the expensive computation you want to work with. So in this case, we are going to pass in expensive. And now there will be situations in which the function you are working with takes arguments. All right, it takes some arguments. So this argument will be, you will enter this argument as part of this add task argument. In this background task dot add task argument, you pass in the arguments of the function that you want to execute. So in this case, we have that the only argument we have is email. Right? So we are going to pass in that email. Sorry. Our email here will be equal to, let's call this test.com. With that, we can remove it over there. So before we test this, do you have any questions?
Okay, we added the expensive function, the expensive that we created into this background task. So, which means it's important for you to add those brackets, right? Because I noticed you didn't add the parentheses after expensive when adding it.
Yes,
This is a function.
Yes, you don't. Yes, you don't add the. You don't add the parentheses. You know, when you add the parentheses, you are executing the function at that point. Right? We don't want to execute that function at that point. We want the background task. We want the background task to be in charge of executing the function. So what we do is just pass a reference to the function and the argument.
Okay, I get.
This, do you have any questions?
Okay, one more question. I think if to understand this background task correctly, maybe I don't know. I'm thinking of an analogy, maybe whether it's the same thing. Let's say now we are performing a mobile transaction, like you want to transfer, like maybe money to someone, and let's say you use your app or use your USSD code, and you dial the code and put all the details, and immediately you press the code to dial. You know, it's normally like maybe if you are transferring money to someone, let's say you are going to POS, it may take some seconds to reflect maybe on the database that, okay, this transfer is made, but you still get a message that maybe transfer has been completed, though you may be waiting for alert, or you may be waiting for maybe the other person, you are waiting for the other person to see it. So maybe you make a transfer and you have seen a message, maybe debit alert, but the other person has not received the debit alert. So is it like the same analogy whereby there is no, maybe is an expensive process. To process a transaction is expensive. So you, instead of waiting until that person receive alert, they just send you a message. I don't know if it's the same analogy there.
Okay, no, it's not the same. I don't think it is the same. I'm going to explain why I think so. So you're going to use background tags for situations in which you need the user to get the result immediately. In the case of a mobile transfer, when that request gets to the back, and you need to process everything. You need to make sure that this transfer goes through before you notify the user that, hey, we have executed your transfer. All right. It doesn't really make sense. Let's say if I'm the one designing that system, it doesn't really make sense for me to just get the data from the user and maybe return the response to the user. It doesn't really make sense because what if the user doesn't have the right amount of money in the accounts to actually execute the transfer? And also, what if there's a network failure? All right. So things like that are critical, they are important. And as such, no one would normally you don't want to use background tasks for things like that. Then as for the mobile transfer you spoke about, there's what they call, I've forgotten the exact terminology, but how this works is that these banks, they have a system that ensures interbank transfers. So let's say if I want to send money from my Zenith bank account to someone that is banking with UPA. All right. Zenith bank does not directly interact with UPA servers. Instead, they send the request to that system. I've forgotten the name. Then that system will be in charge of routing that request to UPA and executing the transfer. Then for them on their own, all right, when the transfer request is sent to that system, they can safely notify you that, hey, we've completed your transfer. All right. Then it will take time for this system to deliver this data to the other bank network, and it will also take time for the other bank to maybe process this data and notify the user that he or she has gotten a debit or a credit alert. So maybe that's why you can send money to someone and you've been notified that you've been debited, and the person hasn't been notified yet. There could be maybe a slowdown in between. It's not really related to background task.
Okay, I get now.
Okay, so we are going to test this now.
Okay, I can't hear you. I don't know if I can't hear anything.
I can't hear him too.
Sorry, it's like I muted myself. Sorry about that.
Okay.
Yeah, you can hear me now, right?
Yes, I can hear you now. Yes.
Sorry, I muted myself. Sorry. So we wanted to test this out. All right, we wanted to test this out. The ideal result will be, remember initially when we didn't use this background task, and when request gets to these endpoints, it needs to wait for that period of time for like the functions to complete, the computation to complete before it sends back a result, right? So now that we are using this background task, the computation will be taken to the background, all right, and we'll get our response immediately. Then another thing you need to take note of is that this expensive function that we are working with will still be executed, all right, but it will not be executed in the normal user control flow. It is taken to the background. So the user gets his result, gets his response, and the computation runs somewhere else and then returns the result. So if we execute this, it will give us a result. Then after 5 seconds, it will print this email to the terminal. So let us test that out. Yes, can you see we have the result? Now look at my terminal. Good. We have this test at test.com printed to the terminal. So please, do we have any question?
Okay, no question from me. I understand so far.
Okay, Mike and MJ, any question? You've not said anything.
It's clear. I'm following you.
MJ, how about you?
I'm also following.
Okay.
So like I can let's say, let me just give an analogy to kind of validate what I think I understand. So which means like in those instances where you're interacting with a web page and you send a request and it brings out maybe something for you like processing or something is displayed on the screen, but the request is still processing on the background. Is this a kind of use case for this?
Yes, this is a perfect use case. When
all right,
you want a computation to execute on the background, you don't want the user to wait for this computation to finish. Good use cases would be things like sending emails, things like maybe file processing. Let's say I'm building a social media API which users will submit audios and videos, all right? And it wouldn't really make sense for me to get this image files and store them like that. All right, it will be a waste of space. It's a whole lot better. It's a whole lot more economical for me to compress these files, right, and then store the compressed of these files. So things like that, you can use background tasks for it. When the user sends it, give the user the response that, hey, your upload is successful, but you don't run the computation to compress this on the background. The user doesn't really need to see that. So this is a perfect use case. All right, so I'm going to commit this and I'll push it to our GitHub repository so that you can reference it later. Okay, before I do that, let me append the link to the background tasks section of the documentation for you in case you wish to reference to that later. So you can go read this up. So there's an interesting question, right? A very interesting question. And I will give you this as an assignment actually, but it doesn't really mean that this will be graded. It will not be graded, but it would help if you can go and research on this, right? So what if we are using an async function here? What would happen? What do you think?
Sorry, async function for the one where your cursor is.
Yes, as you can see, I have changed my expensive function from a normal function to an async function. All right, what would happen? Okay,
Wow, interesting.
that's a good question.
Yeah, it's a very good question because it's running inside the background task function. So I'm
Yes.
wondering how, since we have to await async functions.
So this will not work, but it's not that we'll have an error, right? We will not have an error, but this is what will happen. This task will not be added to the background. It will still run on the foreground, right? But why is it so? That's the interesting question. So I'd love you to research on that. Then in the next class, we are going to discuss that. I'm going to hear what you found out, and we will also go through it together and understand why it is so. So let us send this request again. Yeah, can you see? It's taking time. Yeah, it's taking time. We don't have any error message. No error has been given to us. It's the same code. All we did was to change this from a normal function. Let me show you again. If we test with a normal function, it works as expected. But if we change this to an async function, it doesn't give us an error. It doesn't give us an error, but it also doesn't do what we want it to do. You can see it's taking too much time. All right. So that means that this thing is not working. Like it has not been added to the background. So that's an interesting question, which I'd love you to research on. And by next class, we'll discuss it and perfectly understand why that is so. So I'll remove that for now. Let me commit this to GitHub.
I hope my network did not freeze, or am I the only one that's okay?
It's muted again.
Okay.
Sorry, I'm trying to push to GitHub. All right, so that's complete. You can reference the code later. Now, the next thing we are going to look at is unit testing. All right, this is a very, very, very important part of software development, especially when you're working with languages like Python, in which you know how static typing, in which with this it's very possible for errors to creep into your code, and you will not know until runtime. All right, there's what they call compile time, runtime. So languages that are compiled, languages like C++, Rust, Golang, they are compiled. These languages, it's easy for you to spot errors because I wouldn't say it's easy, but it is easier to spot errors because if there are errors in your code, while they're compiling the program, some of the times, right, these errors will come up. The compiler will check the program. But for languages like Python, JavaScript, and I think Ruby as well, you don't have this compilation. Your code runs on the fly. As a result, you get this error on runtime. Let's say we have an error at this home route, right? So most times we will not know that there's an error on this home route. That's if you do not check your code properly. It's only at runtime. That's when the user wants to run that particular endpoint. That's when the user sends a request to that endpoint. That's when this error will come up, and it's a very serious issue. It's a massive issue when you're working on a huge project. You may not really have time to like check everything manually and all of that. So this is where unit test comes in. When you're writing software, it's always advisable to like write as many tests as possible. For example, this particular endpoint, this home endpoint, I normally I would want to write a test that will check that if a request is sent to this endpoint, this is the response I'm expecting. This is exactly what I expect to happen. Okay, so instead of testing this manually like we've been doing using Postman, you can write some utility code that does that for you. And the advantage of this is that you are free to even when it takes more time to write this code, you are free to run these tests as often as you can. Let's say a test that I wrote today, I can always run it tomorrow, always run it next tomorrow, and it will give me that confidence that the software that I'm shipping to the production environment is error-free, is bug-free. Do you guys get me?
Yes, I get.
Yes, I get.
Okay.
Sir.
So that's why unit tests are very, very, very important. In fact, in practice, like when you're building maybe a real product that you want to deploy for with the clients to interact with, for users to use, you wouldn't really want to ship a product that has not been properly tested. Every single point should be unit tested. Every single utility function, like every single thing should be unit tested. Take for example this expensive function. All right, you would write the test to ensure that when this function is called, it sleeps for 5 seconds, then it prints email. You write tests to check all these things so that it would be easier for you to make edits to the code later on. It's possible for you to inadvertently introduce errors to your code base when you are editing it, when you are making changes, when you are adding new features and all of that. Also, when you are refactoring, you don't know if it still works. Another source of errors is when you are upgrading your package. Let's say you were using maybe version 1.7.0 fast API, and you then upgraded it to maybe if a new version comes out tomorrow and you updated it to the newest version, the latest version, and the particular feature is no longer supported, or maybe a particular API is no longer supported. Or it could be that this background task is no longer available within Fast API, is available somewhere else. Right. So if you didn't have this test in place, it would be difficult for you to identify these errors on time. All right. If you maybe have a project of like hundreds of endpoints, it will be very cumbersome for you to like manually test these endpoints, testing these endpoints, and test these endpoints to check if they are still working. Doesn't really make a lot of sense. So that's why it's important to like write these tests as you're building the endpoints. You're writing the tests for them so that you can always run them later on. Maybe something that would have taken you like hours to test manually, you can use just minutes to test with your unit tests. So we are going to look at that now, but we're not going to a whole lot of data. There are some things that we're not going to look at for now. We'll be using the PyTest package. It's a very popular package for unit testing, and that's what we'll be using. But like I said, we'll not look at everything. There are things like fixtures, right, which we are not going to look at for now. Then there are things like mocking. I will explain that in detail. Mocking is take for example, you have somewhere in your code base that communicates with an external server. For example, maybe you made use of the request library. Let's import requests. And maybe somewhere within your code base, you made a request to, let's say, response is equal to request dot get. So let's say somewhere within your code base, you sent a get request to an external server. Maybe let's assume it is bbc.com. If you are testing this particular endpoint, right, this will be executed. This request will be made, right? Your endpoints, like this endpoint, for example, is going to actually send a real GET request to that server. And it doesn't really make sense. Okay, it doesn't really make sense. But normally for maybe a simple request like this, it doesn't really cost you much. Right? It doesn't cost you much to send a GET request to bbc.com. But what if you have we were talking about emails, right? And most of the times you are going to use an external email API in which you are going to actually send a request that contains the email contents and everything to that API, which will then forward it to whichever user you want to send this, whichever email you want to send this request to. So this email costs money, right? It could be maybe an email could maybe cost $0.001, or a text message could cost like maybe $2 per text message. So if you didn't perform what we call mocking, all right, every time you are running these tests, these requests are happening in real time and it's costing you money, all right. Then apart from the monetary aspect of it, it's not really right to make your test dependent on an external system. For example, if we actually test this, all right, it basically depends on bbc.com. If bbc.com is down, our test will fail. All right, this is actually not proper. So this is where mocking comes in. We use unit test.mock. You can import coming from unit test.mock. You import mock and then use that to maybe mock your request, or not just request. You can mock a real function. You can define the side effects, like what do you want this function to do when it is called, what kind of data do you want it to return, and all of that. So we are not going to look at that now due to time. But from, I think after next class, the next thing we'll be doing is we are going to start working on our project. So this is where we are going to make a whole, we are going to make use of this mocking, the fixtures, and monkey patch, and all of that. So today's class will be all about like just testing. We will assume that these things don't exist for now, but for sure we are going to look at them. Did you hear me? Is there any question on that?
Yeah, no question from me. I understand everything I've said.
Okay.
That's clear.
All right. So we are going to build a simple. We're going to create a simple project, and it will contain a couple of endpoints, right? And we are going to write unit tests for these endpoints. So to do that, I will create another file, then I'll call this main.py. Then, as usual, we'll instantiate a project. I'll simply copy and paste to save time. We're not going to need background task here, so I'll just take it off. Then we are going to use Pydantic. So I will import base model from Pydantic. Yeah, I import base model from Pydantic. So I'll copy and paste some pieces of code here. Then I will explain that. All right, so I want to mock a database. Let's assume that this is our database. It's, of course, a fake database. So we use this to actually store data and get data from the database. So the first thing we are going to do is we are going to create an endpoint that will add data to that particular database. And before we do that, we'll create an item schema. That's the schema of the item that will be coming into our database. It's called item that's inheriting from base model. And each item will have an ID that is of type string. It will then have a title that is of type string. And it will have a description that is of type string or none with a default value of none. This is the newest construct if you are using Python 3.10 and above. I'm going to assume that some of us have an older version of Python. So I'm not going to use that. Instead, I will import optional from type.
Okay, if I'm correct, the way you did it now is for people with Python 3.10 and above.
Okay, it's a new syntax that is that was introduced in Python. Yes, I think Python 3.10. It's 3.1.0. It's a new syntax that was introduced. But it's not everyone that has the latest version of Python. So this would fail if you are using any version of Python below Python. And I wouldn't want that. So I'm going to use our normal optional of type string, then import none. But if your version of Python is up to 3.10, you can use this and there will be no issues.
Okay.
So it will be of type optional. Then optional what? It's optional string. And what will be the default value? Our default value is none. Let me remove this errant import. the first thing I'm going to do is I'm going to create an endpoint, to save time. I'll just copy and paste, then we'll explain. We don't have enough time to type it up. So we are going to create an endpoint that actually adds an item to that database. This endpoint makes use of HTTP exception, and it makes use of header as well. So it's from fast API. HTTP exception and header. All right, so here's what happens. This endpoint at line 24, it accepts a post request, right? And it accepts a post request to the path items. And I don't think we have used response model before, have you?
No, not that I can remember.
No, we've not.
Okay, we show you. Maybe we have not. I don't remember. So this it defines the model that you want to return to the client side. Right? What kind of data do you want to send back to the client side? So you can input the model you want to send, just like what we have here, item of type item. All right. This specifies the model of data that is coming into your endpoint. All right. But to also define the model of data that is going out from your endpoint, you make use of this response model or to whatever model you want to use. Okay, do you get that?
Yeah.
Okay. Then that's that for line 24. Then at line 25, we are creating the function that will be executed when a request comes to this particular endpoint, and it's called create item. And just like the name implies, we want to insert an item into DB. Thus, we want to insert an item into the database. Then it takes this item object, this item schema, meaning whatever data you are passing in should have an ID. Then it should also have a title. Like, can you see here? The existing data in the database, it has an ID. The first one has an ID of foo, the title of foo, then description of there goes my hero. So whatever you're sending in should have an ID, should have a title. And the description is optional. You can provide a description or you can choose not to provide a description. If you don't provide a description, the value will default to 1. And in addition to the item, which will be in your response body, you need to attach a header token. And in this case, we call it X token. It will be as part of your header. If it is not provided, the endpoint will throw a validation error. That's that for line 25. Now line 26 is the comment for this. Line 27, at line 27 and 28, we are checking if this token that is provided from the front end is what we expect it to be. We are performing, let's say, a mock authentication, right? A mock kind of authentication. We want to ensure that this token we are getting from the front end, it is the token that we expect to get, right? And this token that we expect to get, that is fake secret token, is called cone of silence, all right? All in string. So if this token that is provided from the front end is not exactly what we expect it to be, it will raise an exception. And this exception will have a status code of 400. A 400 exception basically means, let me switch to my browser so we can check that out.
That's bad request.
Yes. A 400 means bad request. A 422 means a malformed request.
Unprocessable entity.
Yes. A request in which the backend understands the request but doesn't intend to process that. And you usually send that when the user is entering or the client is entering an invalid data. Then, in addition to your status code, you also need to pass in the detail, like what message are you sending back to the client, and it is invalid X token header. That's for line 27 and 28. Then at line 29, we are checking this item that we got here. We are checking if its ID is already available in our DB. If item.id in fake DB, it means that, like, take this item.id, check the database. Do we already have that item there? So if it is there, it will return an exception. It will raise an exception at line 30 with a status code of 400, and the detail of item already exists. And at line 31, we are actually adding that item to the database. All right, fake item of ID, item.id is equal to this item that you passed. So this is how you add a value to. This is one of the ways you can use to add a value to a dictionary. Then when we are done with that, we simply return this item back to the front end. That's at line 32. So please, any question on that?
No question from me. No, I can understand everything so far.
Okay, so that is the endpoint for adding data to it. Now let me copy an endpoint that you can use to retrieve data from our database. All right, so that's that. We have an endpoint at path items that receives a GET request. Right, please note the other one was a POST request. It is the same path, but this one is a GET request of the same path. Fast API will know if the request is a POST request, it will route it to this first part, and if it is a GET request, it will send it down to the second part. And the response model is picked, meaning it returns a dictionary, just any dictionary. Right? And currently we don't have these dicts imported, but you can do that from typing. I said this typing, you can also import the dict. So with that, we have it imported. So this particular function takes an X token. It only takes an X token, and it validates this X token. If this token is valid, it returns the database, the fake DB, to the client. But if it is not valid, it raises an HTTP exception with a status code of 400 and a detail of invalid X token. Then the last one is we want an endpoint that we use to retrieve a single item. This endpoint is specific items, and it has an item ID as parameter. And it also returns the item schema. So at line 43, the function that will be executed is readmain, and it takes item ID, which is a string, and also accepts an X token, which is a header. Now, if this X token is not what we expect to raise an HTTP exception of status form, then if this item is also not in the database, right? If we're looking for an item that does not exist in the database, it will also raise another exception. And the exception in this case is 404. 404 is usually reserved for item that is not found, an entity that is unavailable. So that's what we use 404. If the item exists, simply returns that item at line 40. So these are the three endpoints that we have to work with. And before we start the unit testing, we are going to test this manually. When we are done, we test it with the fast API unit test class. So I think before you proceed, I would love to maybe pause for questions.
Okay, so the last endpoint you created, that's a path parameter, right? That's a path parameter. Where you put
Yes,
the
that's
item.
fine.
Okay, so if you run this now, the header based on this last two endpoints, you put that header. How is it going to be inserted when you are running it? When you are running the code now, is it? Yeah.
Okay, don't worry. We'll get to that.
All right.
Yeah. So it's possible to insert a header from code. So you can, if you are testing from your request clients, it's also possible for you to insert the header to the request. If you are using your test client from code, yeah, it's also possible to insert the header, and we are going to look at that. Now we are going to start this testing. So the first thing I'm going to test is create items, which accepts a post request. So items, yeah, it accepts the post request. So we are going to change this request type to post, and it also accepts some data. It's supposed to take an ID, title, then a description.
Okay, in one of our previous classes, I think the last two classes, it taught us about form, using form. I think you can also implement it here, right, if you want.
Yeah,
So
yeah,
that
sure.
instead of using JSON request, you just use form.
Yeah, if you wish to, but I'm going to use the JSON request. But you can, if you wish to work with forms, if you wish to do it with forms, it's entirely possible. All right, so let's execute this request and see the response. Unprocessable entity. Okay. All right, so we have an error, and the error is from line 25. Don't forget that we are supposed to provide this header, or this X token header, and I didn't do that. So let me append it to the header. X token. Let me provide an arbitrary data. Of course, this should fail. It will not work. Good. We have we've received a 400 bar request error, and we have the detail that we sent an invalid X token header. I believe that particular exception is triggered at line. It is triggered at line 28. So all we need to do is to copy the right header, the header that we are supposed to attach, which is cone of silence. So we simply need to copy that here and try it again. Good. So our request is now successful. We have received the ID of testing, the title of check title, description of test description. So if we send this again, it should fail. Yeah, it has failed. And the response is that we already have this item. We already have this item. Now let us test the second endpoint. Let us test the second endpoint. The get endpoint, which returns the entirety of that database. It simply dumps the database into the response for us. Good. So this is all the data that we have. We have full, we have bar, and this is the last data we just entered. That's testing, and it's of ID testing, title, my fake title, and description, my fake description. So before we start writing the real unit tests, I would love to pause for questions. Any question?
No question from my end, I understand.
How about
So there
I
are
understand the so
question. Okay, Gilbert, finish.
no questions? So the next thing we are going to do is to write the unit test for it. All right, and we are going to use PyTest for this unit test. So we need to install PyTest, and when we are done with that, we can then start writing the test. Install PyTest. Now, to actually run a test with PyTest, you need to name your test file with this specific convention. Your test file should be named test underscore any other thing. All right. So in this case, it would be test main. Please let me recap. You know, when you are testing your application with PyTest, right, the test files, your test shouldn't be in your normal endpoint file. Like in this case, main.py, you shouldn't put your test here. Right? You should put it in a separate file. But this separate file should be named in this way. It should have test underscore, then the name of whatever name you wish to say there. If we use something else, PyTest will find it difficult to. If you use something else, PyTest will find it difficult to identify the test files and test. So that's why we need tests. Ahmed, do you have a question?
Yes, I have typed it in chat.
Anyway, we can upload the picture of the testing project here. Yeah, definitely. Maybe when we're working on a main project, we'll try that. So to save time, I'm going to copy down one test and we'll explain it. We'll go through the whole thing. We'll run the test. Before we do that, to actually send a test request using Fast API, you need to import test client from Fast API.
I have a question.
Can you test?
I have write it in chat, but you didn't read it. But I'm asking about when you are testing using Postman in form JSON, how can I upload picture? If it's
Okay, we'll look at
possible. Hello?
Yes, I can hear you. Please mute yourself.
Hello?
All right. Maybe before we get to this, let me solve the Hermes question. So I'm going to switch back to my Insomnia client, and we are going to do that. So to actually upload a file to your server, you go to, instead of using JSON, you go to multi-part form. All right. Now, under value, simply click on this, then select file. And from there, you can choose a file and send your request. So that's how you do it with Insomnia. I don't really know for Postman because I'm not using Postman at this point. Let's continue. So to actually send test requests using Fast API, we import test client from Fast API. Fast API.test clients, you import test clients. Then we need to instantiate the test clients with our app that we created initially. So from main, we are going to import the app. All right, the next step is to instantiate the client with this app. So we'll call this client is equal to, we will pass in the clients we imported from Fast API. So that will be test client. This is just like the OOP we learned in a couple of classes ago. We are instantiating the class, and we instantiated this app we imported from our main directory. So with this, we can send a request with this app. So I will copy down test and start working. Okay, I believe you still see my screen, right?
Yes, I got.
Yeah.
Okay. So another convention you need to take note of when writing tests with PyTest is that your test function should also start with the word test, then underscore. Just like the test file, your test function should also start with test underscore, then the name of the test. And in this case, we want to test create item, right? So we can call that create item. Now, if we go to that particular endpoint, the create item endpoint, you found out that this endpoint accepts a post request, right? So this is exactly what we are doing here. Our response will be equal to this client, the client we've instantiated here, dot post. What we are saying here is that we want these clients to send a post request. All right. And where do we want these clients to send this post request to? Now, we want this client to send a post request to the part of this particular endpoint that we want to test. And in this case, the part is items. All right. So that's why we have items at line 12. And don't forget that our part accepts an X token header. So we need to attach that token to the request. And you do that with headers is equal to the name of your header and the name of whichever data you want to pass to the header. Now, the next argument you pass into the request client is the JSON. And this JSON is basically the data you are sending to your server. Right? And in this case, we want to create an endpoint. Okay, we want to test the endpoint with, of course, the standard item that it receives, which is item, which is ID, title, and description. So in our case, ID is foobar, title is foobar, and description is full batters. So from line 11 to 15, we have sent this request. Now, from line 16 to 21 is where we validate the response. Right? We are trying to validate the response from line 16 to 21. At line 16, we want to ensure that we are getting a status code of 200. That's why we have a set response.status code is equal to 200. So if the status code that is returned from this request is anything apart from 200, it will tell us that it will notify us that okay, we have an error at this endpoint. It's not giving us 200 because that's what we expected it to give us. And the next thing is response.json. This JSON method returns the data that you got from the endpoint. This is what I mean. In this case, can you see this response over here? That is like if we were to send this request using our clients and then call REST and then call JSON, this is exactly what we will get, right? So that JSON gives us that response body that we get from making the request. So that's that. And now we want to assert that this response is exactly what we expect it to be. It should have an ID of foobar. It should have a title of foobar, and it should have a description of full batters. So now let us run this and see what happens. You run PyTest tests with simple PyTest. Good. Can you see what we have?
Yeah.
Okay. So that means that endpoint is working, all right? Because this first test has succeeded, right? Now the second assertion that asserts that the response of JSON is equal to this has succeeded. Now let us mimic a file here. Let us assert that this response to status code is equal to 400. Of course, it shouldn't be 400, all right? There's no way it can be 400, but let us check. Yeah, I want to show you how it looks like when your test fails. So in this case, we are telling this test that we expect the response to be 400. And of course, the response cannot be 400, so it will fail. Now let's see what happens when it fails. Good. So if you open your command line, you will see here that test main, has a failure. And it has pointed us to the exact part of the test that there was this failure, and it is at line 17. Can you see this test main 17? It's telling us that that's where we have that failure. Right, that's telling us that that's where we have this error. So if we scroll to line 17, you can see that we were trying to assert that the response code, the response to status code is 400, which is not the case. So let's take that off and run this test again. All right, so it has now succeeded. Please, do you have any question on that before we build more tests for the other inputs?
Okay, for me, no question from me.
Any question?
No question.
None for me.
Just as we test that something is successful, it is also a good practice to test that your app can fail if certain things are not in place. For example, I want to test that if this header is not cone of silence, it is going to give us something else. All right, so that's what I want to test now. And we can simply copy and paste. You can simply copy and paste this, then make the necessary edits. Now, test create item fails on header. So I want to test that this this request would fail if we did not attach the right header. So I'll send a similar request with similar data, but instead of attaching the right header, I'm going to attach a wrong header. Yeah. Wrong header. And in this case, our status code should, the status code shouldn't be 200. For example, look at the code. We had that if this header, if this X token we attach to the header is not exactly the same as our fake security, the token we are expecting, we want a 400 response to be returned. So that's exactly the code that should be returned. So we'll change this to 400. Now, I want to not only check that the response is 400, all right, because the first exception raises a 400 status code, and the second exception also raises a 400 status code. So I also want to check the detail, all right, that this detail is the exact detail that I'm expecting. So I'm going to extract the detail from the response to JSON and then compare it to what I'm expecting. So it will be asset response. Oops, sorry. Asset that response dot JSON. Now dot get response with JSON dot get. I'm going to get a detail key. We want to assert that it is equal to exactly what we're expecting. So that is that. Let us run this test. Good. So we now have two tests that have completed successfully. Now we also have another exception. If this token is correct, then we find out that this item already exists in the database. All right. We want another exception to be raised, and it is also of status 400, and it has a different detail that this item already exists. So I want to test that scenario as well. That maybe if a user is trying to insert an item twice, we should have this error as well. So we will use the correct header this time, which is equal to kernel silence. And this time around, instead of using a unique ID, I will go and copy an ID that I know already exists in DB, so that you can mimic that scenario in which this ID exists. So I'll call this foo, because we already have an ID of foo in our database. Now, as expected, the status code should be 400, and the detail shouldn't be invalid X token header. Instead, it should be that this item already exists in the database. So I will simply copy this and paste it. I will copy and paste it. All right, then let's run that test. See what happens. Good. Now we have 3 test sources. Do we have any question on this?
Okay, no question from me. I understand.
Okay, so why these tests are important is that, why it takes a long time to write these tests, but actually running these tests takes a very short period of time. Like in this case, we executed 3 tests in just 1.43 seconds. And you may not really appreciate that now on a small kind of back end in which we don't really have a lot of endpoints. When you're working on a back end that has potentially hundreds of endpoints, it will be exceptionally difficult to test all this one. So it will be easy for you to maybe, like as you're building the endpoints, you are like testing manually. But the real headache will come when you want to make changes to your code. You want to upgrade a particular library, you want to refactor the code, you want to bring something else into the code. It will be a headache, because how are you sure that this change you've made hasn't broken something else? How are you sure that this thing you've imported to the code has not interfered with another thing you imported earlier? So it is through this test. If you had this test, it would be very easy for you to just run PyTest. Then maybe I can just go somewhere, sit down, take a sip of wait for the test to complete, rather than having to test manually every single endpoint. So that's where this test is really, really important. For now, I'm testing only the main. I'm testing only the create item. But of course, you can test the get items, you can test the read main and the other one. So I'll leave that to you to do on your own free time, okay? Because I believe that's where you really learn. And I'm going to remove these 2 errands out of here. Then I will insert the link to the documentation where this particular section of the where this particular section of the software is discussed, so that you can reference to it if you need to. I would highly recommend that you do that, because you can't really learn everything from the class. You learn a whole lot making this kind of research on your own. That's where you get to discover new things. You get to practice new things. So that's just it. So I'm going to commit this to our GitHub. I'll push it. All right, so this is live on GitHub. You can go to the class repository to pull that and reference it from. So please, before we end this class, do you have any question on what we did so far today? In today's class, to recap, we looked at background tasks, and I explained why background tasks can be useful, and I said something about using it in situations in which you have an expensive computation to perform, and the user doesn't really need to get this result of the computation immediately. So that is where this background task comes in. Then we looked at a small example of this, and I also brought an interesting question in which, if this expensive computation in this case is an async function, this doesn't do what it is expected to do. All right. I've then asked you to go and research on why is it not doing what it is expected to do. We don't have any errors, but apparently the computation is running on the normal user flow. All right. Instead of being taken to a different flow, it's still on the normal user flow. Why is it so? So you have to research on that. Then we started looking at testing. We created a bunch of endpoints, and we then wrote tests for that endpoints, for those endpoints. So please, do you have any questions so far? Is there anything you'd love for explanation?
Okay, there's something I noticed a little bit. The X token, when you defined it in the main file, the X token, you use a small letters like X dash token in small letter.
Yeah.
But when you were putting it in this test file, you use capital X, capital token. Is it that it's not too sensitive?
You can still use you can still use the small this to still work. So the whole thing is not case sensitive. So as you can see, it still works. It's not case sensitive.
Okay.
All right. So please, do we have any other question?
I'm okay with everything.
Right. So I believe there's no other question. So you can go to the repository and check it out. Go through the code. Go through the documentation. If there's anything you don't really understand, you are free to get in touch with me on Slack. I'll be happy to provide further explanation. So I guess that will be all for the class today. Thanks so much for attending. We have Ihama, and the others too that were present from the start. Thank you. That'll be all.
Thank you very much, sir.